So not every star becomes a black hole at the end of its life?
No, because something like the sun,
We have a small star.
It's quite small, yeah. And when it collapses, there's a sort of a pressure which is caused by the fact that electrons don't like to be very close to each other. So it's called the Pauli exclusion principle. But essentially what happens is that, so as they get squashed closer and closer together, they move faster and faster. And that makes a force which holds them up. And so that creates what's called a white dwarf star. You can have a blob of matter. They're about the size of the Earth, but they're about the mass of the sun. That's for smaller stars, things which are very dense. There's another version which is called a neutron star, which is the same thing, but for neutrons. If it's massive enough that it overwhelms the electron thing, then the electrons sort of crush into protons and turn into neutrons. And so a neutron star can be, at least 1.5 times the mass of the sun, let's say, but it can be about 10 miles across. So that's an incredibly dense ball of matter held up by the neutrons moving around. It's called neutron degeneracy pressure.